Hi, my dear students. Good morning to all. Welcome back to Maths online class. How are you all? Hope all are safe and healthy at home. So, we can enter to today's session. Let's see what is today's topic. Today, we can discuss on the second criteria. We are discussing on the topic congruence of triangles. In that, we are discussing the criteria for congruency of triangles. In the previous class, we discussed the first congruence criteria. What was it? SSS, isn't it? Today we are going to check what is the second criteria, that is SAS criteria. So what does the name indicate? SAS. That means side. What is A means what? Angle. So side, angle, side. Now which angle and what is the speciality of sides? That we can check. So what is SAS criteria? From the name itself, it is side angle side criteria. Here see the triangle here. Two triangles we are having, isn't it? In this triangle, this side is 5 centimeter and this side is 5 centimeter. That means in both the triangles, one side is equal. Similarly, here is 7 centimeter, here also 7 centimeter. So we got two sides of the two triangles are equal. Now where they have marked the angle, this angle is how much? 65. Similarly, here also is 65. So that angle they have marked between the two equal sides, isn't it? This side and this side of the first triangle is equal to the same sides of the second triangle, isn't it? In the between that two equal sides we have the angle, equal angle, isn't it? That is SAS rule. What is it? The two equal sides and the angle between the two equal sides should be equal. Then we can say the two triangles will be congruent. So what is SAS congruence criteria? If two sides and the included angle, that is the main point. Here this side and this side of this triangle and this side and this sides are equal. So the angle they have taken is between the equal sides, not this angle or this angle, isn't it? The angle here we are considering should be between the two equal sides. So when you're considering these triangles, the side JK is equal to PQ and the side LK is equal to RQ. And we are considering the angle A, which is between the equal sides, and here in this triangle we are considering the angle Q, which is between the two equal sides. So SAS rule states that if two sides and the included angle of one triangle are congruent to two sides and the included angle of the second triangle, then the triangles are congruent. So if we are able to prove in two triangles, two sides and the angle between the two sides are equal, then by SAS criteria we can say the two triangles are congruent. So once again stating the SAS rule, if two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. Here we are not considering the three sides. We are considering only two sides and the angle between that two sides. Here AB and DF, that are the equal sides, because AB is having 5 centimeter and DF is having 5 centimeter. Similarly, AC is having 6 centimeter, D is also having 6 centimeter. So we got in triangle ABC and DFE, these two sides are equal. Now which angles are equal? Angle A and angle D are equal, and we have this angle A and D are between the equal sides, isn't it? The angle is coming between the equal sides. then we can apply SAS criteria. Then only we can apply SAS criteria. If these two sides are equal and if you are getting this angle as equal, then we cannot use. If you want to use angle B, the sides should be AB and CB. Similarly here DE and EF. If you want to use angle C, the sides should be BC and AC. This here EF and DF. So the angle should be included between the two equal sides. Then only we can apply SAS congruence criteria. Now we can solve some problems on this criteria. In the figure, this is the figure. AB and CD. Where is AB? This is AB and this is CD, isn't it? AB and CD bisect each other at O. That means AB and CD are intersecting at a point O, which means bisecting means this O divides AO and OB into two equal parts, OC and OD into two equal parts. Bisector means it divides the line segment to two equal parts. So from the question itself we have AO and OB are equal, OC and OD are equal. Now the first question, state three pairs of equal parts in the two triangles. Which are the two triangles? AOC and BOD. These are the two triangles. We need to state three equal pairs in these two triangles. So from the question itself they have given you two equal parts. What are they? AO and BO will be equal, OC and OD will be equal. What is the reason? Since O is the bisecting point, AO will be equal to OB. So we got one condition. AO comes in this triangle and BO comes in the next triangle. So we got one side is equal. Similarly, CO and OD will be equal. CO comes in this triangle and OD comes in this triangle. Now you have to get, if you want to apply SAS rule, we need to get one angle. So which angle we should consider? Which are the two equal sides? This side and this side are equal, this side and this side. So which should be the angle? This angle we have to consider, isn't it? Can you say this angle will be equal or not? Can anyone say what will be the reason? I am saying the angle AOC and BOD will be equal. Can anyone say the reason what it will be? You have studied in your 5th chapter what is that reason. From the figure itself you can see. Yes, very good. They are vertically opposite angles, isn't it? AOC and BOD are vertically opposite angles. You know the vertically opposite angles will be equal. So we got the three pairs. Which are they? This side and this side we got equal. This side and this side we got. Then one angle also we got equal. They just asked you three equal parts. They didn't specify that three parts should be side or three parts should be angle. Parts means either you can say angles or sides. So from the question we got three equal parts. Which are they? Two sides and one angle. Now what is the second question? Which statements are true? From the first question, we proved the three equal parts. By that parts, by SAS rule, we can say these two triangles are congruent, isn't it? Now, how will you write the congruent relation? Whether AOC and DOB or AOC and BOD. That means I said that when you're taking the correspondence, it should be correct, isn't it? So, if I'm taking AOC and DOB, see, AO is equal to DO. Isn't it like that? AO is equal to BO, it is not DO. So, this corresponding is wrong. Now, check the second correspondent, AOC and BOD, the two triangles. Here, AO. Here, the side is AO and BO, isn't it? We are getting or not? AO equal to BO. Next, OC and OD. OC and OD. So, we got the correspondence correctly. So, which will be the correct one? Triangle AOC congruent to triangle BOD. So, when you are writing the congruence relation between the triangles, I said that sides should be matching. Next question. Here, what is this shape? You know, this is a four-sided figure. If PQ and SR and QR and PS are parallel, we can call it as a parallelogram, isn't it? Now, we cannot say they are parallel. Anyway, it is a quadrilateral because four-sided figure, we call it as quadrilateral. Now, what is given here? Two triangles you can see here. Which are the two triangles? This quadrilateral is divided by a diagonal, isn't it? This diagonal divides this quadrilateral into two circles. Sorry, two triangles. Which are they? SRP and QPR. Now we have to prove these two triangles are congruent. So they have given you some measurements, isn't it? Which is this is 3.5 centimeter, this side is 3.5 centimeter, and this angle is 30, this angle is 30. So how can you prove these two triangles are congruent? For proving the triangle congruence, we have studied two congruence criteria. One is SSS and one is SAS. Here they have not mentioned about the third side, so we cannot use SSS. Now the other one is SAS. So just look, can we apply that? Here what it is. This side PQ and SR having same length. This is 3.5 centimeter. So we have SR and QP are same. Now this angle QPR and SRP are same. What is the angle measure? 30 degree. Now we got this side and one angle. Now we have to consider the third side. What is this third side? PR. That third side PR is common in both the triangles. When you consider the triangle PSR and the triangle PQR, the side PR is in both the triangles, which means PR is a common side. Therefore, PR will be equal to PR. So what we got? This side and this side are equal, and the angle included between the two equal sides are also equal. Then we can apply what? SAS congruence criteria. If you want to apply SAS criteria, we want two sides and the included angle, isn't it? That included angle we got and two sides also we got. So by SAS criteria, we can say that two triangles are congruent. So once again, PQ equal to PS. It is given in the question that these two sides are 3.5 centimeter. Now these two angles, this angle and this angle is given 30 degree. That is also same. Now the third side PR is common side, which means that side is also equal. So by SAS criteria, we can say triangle SPR is congruent to triangle QPR. In this way, according to the given conditions, you have to decide whether we have to apply SAS congruence criteria or SSS congruence criteria. According to the available facts, we have to prove the congruency of triangles. Now, two more congruence criteria we have to discuss, that we will discuss in the coming classes. So, that's all for today. Hope all of you understood today's class. Try to work out more problems on the concept we learned today. Copy down the notes given and attend the test paper. We'll meet with the next concept in the next video. Thank you.